Yeah, hi there. In this time series tutorial, we are going to cover Holt-Winter's multiplicative method. In the previous, we covered Holt-Winter's additive method. So, so what is a Holt-Winter's multiplicative method? So, just like the additive method, it again captures the level, trend, and seasonality. The only difference is that instead of using the additive term, here we are using the multiplicative term. That is what is called as a Holt-Winter's multiplicative method. So let's see what is the forecast equation and what are the equations for the different components of a time series. So first is the forecast equations, that is y hat at t plus 1. So this is a forecast y hat at the time t plus 1. So this is equals to lt plus bt, and now this term is multiplied by st plus 1 minus m. So in additive model we were actually adding it, but in the multiplicative model, so we are multiplying it. So lt is the level at time t, bt is the trend at time t, and st plus 1 minus m is the seasonality value, m season backwards. For example, if this month is July 2020, then we would be interested in what was the seasonality value in July 2019. So the same value the previous in the previous season. So LT is the level at the time t. It is equals to alpha, which is the level smoothing parameter. So this is multiplied by yt by st minus m. That is yt is the observation at the time period t, and st minus m is uh, the seasonality value m period backwards, and plus 1 minus alpha times lt minus 1 plus bt minus 1. So lt minus 1 is the previous level and the previous trend. Bt is the trend equation. This is given as beta times lt minus 1. So basically beta is the smoothing parameter for the trend. It is getting multiplied by the trend. We can find the trend by subtracting lt minus 1 from lt, plus 1 minus beta times the bt minus 1, which is the previous trend. Now st is the seasonality component, and this is equals to the gamma, which is the seasonal smoothing parameter, and this gets multiplied by yt by lt minus 1 plus bt minus 1. So yt is the value at the time period t, and lt minus 1 plus bt minus 1 is the previous uh, previous level and the previous trend, plus 1 minus gamma times st minus 1. That is the value of seasonality m index back. So so basically what we do, we don't have to manually calculate all these equations. What we will be doing is we will be using the module, which is the exponential smoothing module in the Holt Winters package. So let's see how we do this. First, we are importing the NumPy package, pandas package, and matplotlib.pyplot. Now, from the statsmodels.tsa.holtwinters, I'm importing the exponential smoothing. So we'll be using the same dataset, airline traffic dataset. First, just reading the data into data frame, setting the columns, setting month as the date time column, setting the index as the month column. Now, any missing value in the passengers column, just interpolating it using the linear method, and setting the passengers as the integer data type. Now I'm splitting the dataset into two, train and the test. So train contains 0 to 119 index, and DF contains 120 index onwards. Now comes the important part where we have to apply the Holt-Winter multiplicative method, which basically captures the level, trend as well as the seasonality. So how do we do? First we have to, since we will be doing a forecast for the test dataset, so we have to first take a copy of the test dataset and store it in a different object, basically a different data frame. So we call it as y hat HWM. So y hat is basically we are going to predict or forecast. So that is the reason why I have named it as y hat. And this forecast is based on the Holt-Winters multiplicative method, HWM. So this HWM stands for Holt-Winter multiplicative method. So that's the reason why how I have named this particular object. Now what we have to do first is we have to create a model. So how do we do this? Exponential smoothing, this is what we had imported. So in the exponential smoothing, we have to pass the data based on which the model will be created. So we have to pass the training data. The train data contains train.passengers column. I'm passing it as an array. Now we have to specify the number of periods in a season. Since we have 12 periods in a season, so we have seasonal underscore periods as 12. Trend, I'm passing it as additive. That is, uh, there is a positive trend, so it is additive. And seasonality, I'm saying it's a multiplicative in nature. And then after this, I'm just calling model.fit optimize equals to true. So what it will do, it will create the best or that is optimized values for the smoothing parameters, that is alpha, beta, and gamma. And we can print those parameters plus other parameters of the model using model underscore fit dot params. Okay, now and then once we have got the model fitment done, we have to just do the forecast using model underscore fit dot forecast and the number of periods for which we want to create the forecast. Since we want to forecast for the same number of observations as present in the test dataset, so I'm just passing it as the length of the test. So it will, since it has around 24 observations, so it will forecast for the 24 next months. I'm storing it in the new column forecast underscore HWM in the same data set y hat HWM. So if you see, these are the parameters that model was able to generate as an optimized values. That is, smoothing level alpha is 0.38, beta smoothing slope is 0.035, and gamma is smoothing seasonal 0.617. Now, another thing to notice, initial seasons is coming in the form of an array. So it is, since it is a multiplicative model, so it is coming as a form of an array. Now, we know the forecast values. So what we have to do, we have to just plot it to see how our forecast looks like compared to the actual train and the test data. So we'll use again the matplotlib's PLT method to plot the train data, test data, and the y hat HWM forecast HWM. So Holt winter multiplicative forecast that we had generated, so that we are plotting and setting the labels and title accordingly. So this is what we get. So blue color is the trend, is the uh, train data, and this orange color is the test data, and the green one is the forecast using the Holt winter multiplicative method. So if you see, this is the forecast green color. It's very close to what we observe in the orange color. I think in the additive model also we saw the similar forecast, which was very, our forecast was resembling very closer to the actual values. So it means our model is able to do the good job. And if we just see the errors, that is the root mean square error and the MAPE, so we get values as 34.87 and 6.92, which is very close to what we observed in the additive method. So in additive method it was something around 35, and MAPE was I think around 7 itself. So using either the Holt Winters multiplicative or the additive model, we are able to do a better forecast compared to the other methods that we learned, because as you know, in the Holt Winters method we are able to capture all the three components of a time series, that is the level, trend, and the seasonality. So yeah, so that's it in this tutorial. Thank you.